Okay, and now we are ready to start. So good evening, everyone. This is Celeste from the New Haven Free Public Library. And here we are with another session of Learn to Code, Create a Game from Ives Square with Page. So I think this is our third session, correct, Page? Okay, so we are here in Facebook, we are in Zoom. If you have the link, and I'm gonna be sharing the links as we go with the details of the session. And if you guys have any questions, please just let me know. I'm gonna be monitoring the chat, or you can raise your hand in Zoom and you can go live or put your camera as well. All right, so welcome and so happy to be here again. Hi, Paige.
Hi. Yeah, I'm also excited. Yeah, today's session is going to be really cool because the first session we talked about game engines generally. In the second session, we learned about the game engine that we're using specifically. And today we're going to actually do some pretty substantial code for the game itself. So if you were mainly excited about the coding specifically, today we'll do that. So cool. Also, just some stuff to begin with. First of all, I'll share my screen. Just going to be there. Okay, Celeste, can you see that?
Yes, I can see that.
Okay, great.
And we can see it in Facebook too.
Oh, awesome. Okay, good. Yeah, so first, just starting off, for people that are newer or people that are just joining, either way, these are the notes for today's session. You can get there at this URL. I posted it in the Zoom chat, and I believe Celeste, you posted it on Facebook, so good to go there.
Yeah.
Awesome. Okay. Also, just want to really quickly mention that I have office hours every Monday, and those are from 6:30 to 8:30, and I'll post a link at the end to remind everyone again when my office hours are. So if you have any questions at the end, you can schedule. You can also just reach out to me and ask via email if you want to set up something else. So, okay, that's pretty much all the bookkeeping. Okay, so getting started.
But it's important.
Yeah, you're right. Okay, so part 3. Today we're doing 2 core things. We are going to move the player, really that should say move the character like in the game. The player I'm going to use typically to refer to the person playing the game. And that distinction is useful because there are aspects of the game that we want to be satisfied for the player, and from that perspective, and then whoever the player is controlling, that might be a little bit different because the player might control different aspects of the game. So it's, the distinction is kind of important. So I should correct this to say moving a character or something like that. And then the next thing, simultaneously, we'll kind of be animating some aspects of the game. So animation, a little bit of that, and then also a little bit of movement. Okay, so jumping right in, if you are new or you're following along, basically, I already have a project posted to this website that you could use immediately if you want to. If we go back up to the top here, Library Game Series, you could download this folder and open this project file using the Godot program. I have a link to download the Godot software in here. Yeah, you can click this and you can get started if you want to download and like follow along. But of course, it's okay if you don't follow along like one-to-one. All these notes are going to be up here for you to use later on if you want to do it at that time. So it's okay. All right, so basically, if I open Godot, it's going to look like this, which we talked about last time. This is the project manager list. So I have these two options here. This one is like, I'm not going to use this. I'm going to use this one. This is the one that I have uploaded right now. So if you're following along exactly, you should see the exact same project on your end. Like this is what is uploaded there. Okay, so that being said, the first thing I notice is that we're actually missing, I'm gonna delete this collision shape 2D because we're gonna re-add it as part of the instructions. But another thing is that you'll notice that there's just like kind of like this weird empty space. I added animation frames, which are supposed to show here for our main character, the castaway. And I did this last session, and in the GitHub project, when you upload it, they get disassociated. But instead of adding them back, I'm just going to show you that process because I didn't get a chance at the very end to show it last time. We just really quickly used this little icon, which looks like that. And we just put that icon on the screen as our character. But this time, I want to really quickly show you, apart from the notes, how to associate your own art with like your game characters. So basically, from the last session, we introduced this animated sprite node, which allows you to configure your own custom animations for like an agent in your game, or pretty much anything you want. But we're working with a 2D node. So this is a 2D game, and we have a 2D character on the screen that we're going to add art to. Godot makes this pretty trivial. Basically, we're going to click on the animated sprite. You'll see that under this animations little window here, which pops up when you click animated sprite. I already have a bunch of what are called frames for the animation, but they're all blank. And that just happened when I uploaded it to GitHub. I think I accidentally dissociated the art that I uploaded, but that's okay. We can repair it pretty easily. And at the same time, I'll walk you through this process, which is very trivial. So I'm going to select an animation on the left-hand side. We have two animations, which we're going to use for the main character in the game. There's an idle animation and a walking animation. So I'm just going to delete all these existing frames. Okay, so now we just have two empty animations. For the first one, what I'm going to do is I'm going to click this key here. It's adding frames from a sprite sheet. You can click that. And if you go into the art folder, which I uploaded to GitHub, you'll find that there's two assets. There's an idle and a walk asset. We're editing the idle animation, so I'm going to select the idle asset. I got these assets from like a free provider. I have this little text file in here that gives you a link to the person that created the assets. So I noted this in the last session, but whenever you use people's art, you should attribute them. Or sometimes people will post game art and they'll tell you how they'd like to be attributed or credited. Just make sure you do that because obviously you want to credit people whose art you use. If you like it, or if you want to include it in a game that you're going to make. Okay, so basically, I'm going to use this idle PNG. When I open it, a lot of game assets, when they're produced, basically what people do is they include the entire animation loop in a single PNG. And then they basically just break it up into portions for the sprite. The sprite is this little sort of character right here. So it's like just a generated image that can be used as an asset in a game. It doesn't have a super strict definition, but Godot that often use like a PNG file. And basically what this artist has done is they've basically just drawn 8 different versions of this character, which we'll see more clearly if we zoom in. He's just kind of like this, just this little guy with a face and arms and legs. Nothing super special. And what I'm going to do is I'm going to adjust the frames over here so that it aligns with the individual instances of this drawing of each individual sprite. So let me just show you what I mean. So I'm reducing the vertical. This is the default that Godot sets you up with. We don't want to use that because that cuts him in half. It cuts them in a way that we're not going to really find useful. So I'm going to reduce that down to 1 vertical slice. And then I'm going to increase the horizontal slices until they line up well enough with the sprite. So this one's pretty good. So I have 18 horizontal slices and I have 8 pretty clean frames. I'm only going to use about 4 of them because if you notice, they don't line up very well with some of them, like where it's centered. Actually, I'll go ahead and include all of them and you'll kind of see what the effect is. So we'll go ahead and add these 8 frames. So it should show up like that. And now we're just going to do the same thing for the walk animation, except we'll use this other PNG. So open that up. And I have a link to download these if you want to download them yourself in the previous session notes. But I also included this in the GitHub repository. So this one doesn't line up as well for the walk animation. It lines up okay for some of them if you keep kind of zooming. I'm just going to grab the best fits. So these are all pretty good. And I'll just use these 5. So you can see. Also, if you change your frame size, it actually changes the size of the frame. So maybe we don't want to do that. If you, I think it'll show us what we picked. No, it won't. You just kind of have to remember what you picked for the last one. So I'm going to delete these and actually do it again. And I think I did 18 or 19. 19 will probably be okay. So yeah, it's just not, it's not the most tweakable interface, but it works well enough. I think these are all pretty good frames. I'm going to leave this one out because it's close to the end there. So these, as you can see, are much closer in size to these, whereas before the walk frames were blown up because I took smaller slices. So it zoomed it in. Okay, so these are our frames. And now you can see on the screen, it's going to display the animation that it sees as the default. The default animation shows up right here. So on the animated sprite node in the inspector, you just see animation idle. If I switch it to walk, it'll switch to the walk animation. So you can see how it toggles there. So idle, walk, idle. And you can adjust like the resolution, the dimensions of the frames. I don't know. I don't really mess with it. I just use the kind of how it comes across with the asset that whatever the artist provided. You can also, of course, make these yourself. You could use Microsoft Paint. You could use something like that. You could make your own sprites, animate them. You just need to turn them into PNGs and then adjust the transparency, which I think is the alpha. It's typically what it's called. So if you're into art, then it would be worth your while to spend a lot of time doing this. I mean, I like making art a lot, but I did not do it for this. So I like these assets. They were cool. So I think they work fine. Okay. So now that we have animation frames set up, we can kind of resume the rest of the tutorial. I will go ahead actually really quick and save this. And I will upload it so that if you want to use this, you can, because
Do you make that little guy Page?
no, I did not make this. Yeah, no, I did not.
Looks funny.
Yeah, but I have this source for the little guy in the notes from the last session. So if you want to go download it, you can. Okay, I'm going to go ahead and commit this so that if you don't want to go through all that, you can just download it with those updates that I just made. Okay, great. So that's updated on the website if you want to just go ahead and use that. All right, so now we're kind of resuming with the notes. Okay, let's see here. So the first thing that we need to do, picking up after the animations, is we want to add a collision shape. It's called a collision shape 2D node in Godot. This is putting us on the pathway to physics. So we want our game to have some semblance of physics. There are certainly games that don't have physics engines. There's games where they're text-based games, they're point-and-click games. Even those games technically have physics because your mouse is moving in an XY coordinate plane. Yeah, I mean, usually you have some kind of spatial awareness in a game, and we want to be able to support that. So what we're going to do is add a collision shape 2D, which basically is going to describe our characters' sort of presence in the space that we're creating for this game. So quickly, what we're going to do is we're just going to add this node. I'm going to right click here. You can also just click this plus button. Either way works. I'm going to right click. I'm going to add a child node, and then I can just search in here. Collision shape 2D. And I just double clicked it. And what that did is it added another node, a sibling to this animated sprite underneath the scene node for the castaway, which is just, by the way, castaway is just like a made up name. You could call it whatever you want. It doesn't matter. And then what we want to do is choose a shape property from the inspector on this node. Okay, so what does that mean? We're going to go over to the inspector on the node, which is the right-hand side here. And we're going to click the shape property option list. This is going to give us a bunch of different shapes. Basically what this is a shape that describes the shape of our sprite. So this sprite, we want to find a shape that matches this sort of a best fit, because this is how we're going to represent like collisions in the world. We're going to model our sprite colliding with stuff. Our sprite inherently doesn't collide with anything. It's just a point in space. You can see actually this like little red crosshair. I mean, that is the point that currently represents our character. And that's not enough. We might want to do things where the character pushes up against something and collides or something like that. And that's going to be based on the shape of our sprite. So we want to try to basically best fit that shape. So clicking on this and dropping down the shape, you got a bunch of different shape options here. As you can imagine, these would come in handy for making different like environmental assets. Like if you had a tree, you might use a couple of these shapes, like maybe a line shape and then like a circle shape. you got different polygons, etc. So I'm going to use this capsule shape, which is at the top. And you can see when I click it, it automatically overlays with my sprite. And this is a pretty good fit already. I mean, this is not bad. It's a little bit off, that's okay. You just imagine like, what would your character, what would you want it to look like if they run into a wall or an item or something like that? Like, do you want it to collide, you know, out here or closer to them? I mean, I usually try to make it, or not usually, but I would in this case, try to make it pretty close. Because the idea is like if they're colliding with something and then that produces some behavior, you want it to look semi-realistic. If we put it all the way out here, they're going to collide with stuff at this point. And that won't look very realistic in your sort of physics simulation. So I'm going to pull it in a lot. And I'm going to make it kind of here. This way, if this hand touches something or their head touches something, it'll look substantially sort of like a real collision. Okay, so I've set the shape, and now we can collide with the world. What we can do actually at this point is save the scene. I just pressed Command S, Control S. You can also just go to Scene and click Save. And now we can press the play button again. If you remember last time, if you were here, basically, all we had was like a little icon on the screen. Now we have this sprite. It's starting to look like a little bit more personalized. But if you notice, the sprite doesn't do anything. It's not capable of, we can't interact with it. We don't have any other control over it. So that's what we want to introduce. And we need to do that with code. Okay, so before I keep going, does anyone have any questions on anything? Feel free to you can just unmute, or you can raise your hand, or you can put in the Q&A, or you can chat, like whatever you need to do. But feel free to interrupt me. It's definitely for the people in attendance, so I want to make sure you're able to follow and stuff. If not, then we'll keep going. Okay, so going back to the notes, what we want to do is control the castaway. Let the player control the castaway, which is this sprite. The idea here is to add a sequence of responses to events that the engine tells us about inside of the control for this scene or this node. So we basically want to say, we want to ask the game engine to tell us when the player inputs different keystrokes. Okay. So first we have to introduce these particular events. We have to tell the game engine that there are certain events that we want to know about. So basically going to do that now, you're going to go to project settings, and you're going to go at the top tab here, go to input map. This is going to show you all of the different inputs that we can respond to currently, or that are registered. We want to register our own for controlling the character. I am going to control the character with the arrow keys on the keyboard. You could use WASD, that's pretty common as well. It's whatever you want to use, but we're going to kind of follow this basic scheme here, which is that we're going to add mappings for each input that we want to handle. We're going to give them a name, and then we're going to press the key that we want to map for that event. So first, as an example, move left. So if we want to move left, the player is going to input something, and then we're going to move the character to the left. I'm going to click add to register it. We're going to move right. We'll want to move up. We'll want to move down. I'm just pressing enter to quickly register this. Okay, so now we have all these mappings, but they're not mapped to anything. So the way we're going to map them is with this plus button. So there's a couple of different options here. If you want to map like mouse keys for your game, if you had like a point and click, or you had a controller, like you wanted to do controller support, you could do that. But we're just going to use a key here. So for this one, we're moving left. So I'm going to press the left arrow, and you can see it registers. Notice if you wanted to support a controller, we could still add another option. Like for example, since this is a like a joystick, we could say, left stick left. That would be like moving your joystick to the left. And it's looking for a device that we have mapped currently, or if we had one plugged in, it would pick that up. I don't have one, so it's not going to do that. But you can see there's kind of like default options. Okay, so I'm going to quickly add these other ones. So press a key again, go to the right, press a key again, go up, and we're going to key in down. Okay, so all of these are mapped. You can close that. Now that we have these mappings in place, we can actually use them with a script, which is basically where we're going to code our own behavior for this character in our game. So we're going to start what's called a script in Godot. The way we're going to do that is we're going to click on this castaway node. This is what we want to script behavior for. You can do stuff at the node level. If we were to add a script here, it would attach the script only for the animated sprite. But we want to do it at the sort of the top level for this whole scene. So we're going to select this node, which represents the scene that we're working with, which is basically our character. We're going to right click it and attach a script. It's going to auto-populate a bunch of stuff. Specifically the scripting language that we're using, which is GD script. I'm going to introduce some other scripting languages later, I think, but for now, we're just going to get started with GD script. But hopefully we'll use C# later on, which is like a far more widespread language, and take the opportunity to kind of learn some of that. But right now, we're just going to use GD script. And we're going to make sure the file name is castaway.gd, which it is right here. All of this stuff can stay the same. We're going to create it. Two things happen when you do that. First of all, it gets added over here on the left. So you can see in the file system view, we get this castaway.gd. .gd is the file extension for a script. And then basically, we switch over to this script view, which is showing us the current content of our script file. Yeah, this has got a bunch of code in it already, but none of it is doing anything for two reasons. First of all, these lines are comments. So in Godot, I can zoom in here. In Godot, in GD script, which is the programming language we're using for this, anything with a comment indicator, like this hashtag, it doesn't execute. So if I run this code, it's not going to declare member variables. I mean, it's indicating that these are examples, but the reason they are examples, the reason they don't do anything is because of this little indicator here. Notice that this stuff is highlighted differently because it's not prefaced with this indicator. You can also put comments at the end of lines, and they don't have any effect on the line content itself. So as far as like the game engine's concerned, when it runs this script, all it sees is that there's a function called ready, and it contains pass, and that this script extends area 2D. That's it. That's all it knows. It doesn't really care about the comments at all. Okay. The top right of the script view, by the way, has convenient documentation and help links. So if you see something in your script, for example, like this ready, you're curious, what is ready? Why is that here? I can search ready and it'll pop up. And I can click it and it'll give me the documentation on ready. So it'll describe what the ready function is. So it's called when the node is ready, when both the node and its children have entered the scene tree. So basically when our scene is loaded. And if it has children, all the child ready functions get called before this ready function get called. So basically you can always access documentation in Godot very quickly if you want to understand a concept of the code. Okay. Lastly, I just want to note that at the top of the script, the difference from basically just making, if you go up here, for example, and let's say I just say file new script, for example. Instead of right-clicking the node and adding a script that way, if I go back over to the script workspace, if I just say file new script, it's going to put all these defaults in. For example, it'll say node. It's not going to give me a name and stuff like that. Let's say I just create this script. Notice that it extends node instead of area 2D. Area 2D is a specific type of node. In fact, it is this type of node right here. Our castaway is an area 2D node. That's really the most important thing here. It basically is saying the script is going to have access to properties of the area 2D node type. Like we want to work with the qualities or the properties of this area 2D node. We could use this script, but by default, it isn't the most appropriate. We could just change this though to be area 2D. And notice that it actually suggests area 2D as I start typing it out. I could click that. I could also tab. So if I use the arrow keys and select an option, I can tab and grab it. But we don't need this script. And I'm going to discard it. Okay. So back to the castaway script. We need to add a couple of variables to start off with. The objective here is to basically respond to player input controls and then move the sprite on the screen. So a couple of things that we're going to want to know about in order to move the sprite. So that's our objective. So we're thinking, when we're adding these variables, we're thinking about what we need to know about the space we're working with in order to move the character. So first thing you can think of is how fast do I want to move the character when I move it? So the player, they're just inputting a direction when they're playing your game. They're not saying how fast it should go, so you have to decide that. So that's one thing. The next thing is when they move, when should the character stop moving? Like at what point should the character stop? Like how do we contain basically the character, the sprite, so that it doesn't go off screen? So we're going to handle those two pieces of data with variables, and variables generally are how you're going to handle pieces of data in a script. So we have this template code here, which is actually setting up variables, but they're commented out. So we can kind of use this template as an example of creating variables. So I'll do that. So the first variable that we want, you can also just copy this code I've provided here, which goes step by step, but I'll kind of write it out manually. So variables are data points that we can modify and use to create behavior, and we're going to create two of them now. So the first one that we're going to make is the variable speed. I'm just going to undo this comment. So there, speed. like that. And I happen to know that the speed I want to work with is basically in terms of pixels. So if we go back and look at our 2D space, you can see these kind of this meter, this rule at the top and the left. These are pixels, this pixel distance. So this is actually saying that this is from 0 to 500 pixels. This puts me at 600 pixels right here. So the display that we're working with when we click play, so this is 600 by 600 pixels. So what we're defining in this script then is basically how many pixels the character is capable of traversing per second. So I'm just choosing 200. That seems pretty reasonable to me. Basically, every 3 seconds, you can get across the whole screen. I feel like that's fast enough. We could tweak it though if we want. And we can tweak it really easily if we use this export keyword. So if I put an export keyword in front of a variable using Godot, it's going to let me adjust the property outside of the script. So that's really useful for something like speed, because we can be playing the game and we can adjust it manually. Notice when I put that export keyword in, if you carefully watch the inspector on the right-hand side, if I add that export keyword, it throws the property into the inspector. So now we can adjust it from here. Just keep in mind that if you adjust it here, it's not like going to change in your script. And in fact, what Godot is going to do is check this node property first. And if there's a value set, it's going to use this. So if you're confused why your code isn't working as you thought, make sure you didn't like override it with an inspector property. But we're going to make another variable from the notes here, game window size. So that's the other one we wanted. We just want a piece of data to like a data point to store the size of the game window, because we're going to reference it later when we're moving the sprite. Okay, so I'm going to save that. And I'll run it and note, I mean, nothing changes. We still haven't done anything to move the character. So we've just added variables, but we know it's not broken. So that's good. So I'm going to close it. Okay. So, and when I name variables, I'm going to stick to this convention, generally speaking. So I'm going to use lowercase letters, and I'm going to use underscores to separate words. So it's easy to read that way. And the way Godot writes function names, which we'll learn about in a second, they put an underscore in front of their special functions. So this is a special function, this is a special function. But if I write a function, I'm not going to put an underscore in front. That's to distinguish between an engine level function and then a sort of a function that I've written. Okay. And we've already looked at the script in the left-hand side here, the file system. Okay, so what we're going to do is next we're going to try to consume these variables. Well, actually, we're going to basically set up the scene. That's pretty easy to do. Godot provides you a function, or the game engine provides you a function hook, what would be called a function hook, or a typically called like a lifecycle hook or something like this, which basically says, hey, as I'm setting everything up for you, I'm going to call this function, meaning I'm going to run the piece of code that's inside of this section of your script, and I'm going to run it once you're loaded. So basically, I load you, and I'm going to call this piece of code to execute. So put whatever you want in there that you expect to run right when you get started. And you can see here it kind of says the same thing. So called when the node enters the scene tree for the first time. So that's great. Okay. So yeah, basically what we're going to do is, I already kind of explained all this. We're going to set the game window size variable in here because we figure that we want to know that as soon as the game sort of loads so that the player can begin moving the character. And we can get that information immediately once the game loads because we've set the window size on our project. So we can get that information once the project is loaded and the game is running. So the code for doing that is going to be here. So basically, instead of this pass keyword here, which just means basically don't do anything. That's what this pass keyword is doing. We now want to do something. We're going to set the game window size. It's actually going to start suggesting the name game window size because I started typing it. You'll also notice that it's going to highlight it red, a line red if there's a problem, and it'll try to explain the problem to you. So it's saying you don't have a variable called game window size without an E. So it's going to keep showing that basically no matter how much code I write, it's going to keep giving me that error, and then it'll give me other errors potentially if I keep going. Yeah, that's really helpful. So if I fix that, then it'll change the error to something else because I didn't complete this statement, etc. It kind of keeps up with you. So what we need to do is get the size of the window. And the way we're going to do that is actually this area 2D has a property. It has a function called get viewport rect, which is just like get viewport rectangle. I'm going to do that. I'm going to call that function. When I call this function, it's going to return what's called a vector, which we'll learn a bit more about in a second. And I'm basically, well, rather, it's not going to return a vector. It's going to return sort of a special object, you could say, or piece of data. And I'm going to reference that piece of data to get one particular property. So this part returns a special structure, and I'm accessing that structure, a property on that structure, and requesting just this particular piece of data, which is the size. So I'm going to say game window size is equal to, request for the viewport rectangle, give me the size of that. And I just note here in a comment, because of this little symbol, that it's a function provided by Godot. I didn't write this function. Okay, so this is going to give us the size of the game window, and we can use that later on to constrain our character to the screen. So good stuff. I just want to note that the indentation that I'm doing here, so notice I indented this, and you can see the little tab character symbol. That's indicating that there's a tab character. That is critical. This would not work. Notice it gives me a little error. I have to indent. What that says is basically that this code executes when this function signature is called. If I put it without an indent, this is no longer associated with this function. You would say it's out of scope. Scope is typically the term used for this. So if I put this line here indented, this is in the scope of the ready function. Okay, just important note on that. That's just how GDScript does it. Other languages, indentation doesn't matter, or what you typically call white space. So this would be white space, like is white space enforced. Python, as an example of a large language, Python requires that you use white space to indicate scope. A language like C or C#, it doesn't matter if you indent or use white space. for this particular like scoping purpose. So just something to keep in mind. Okay, so the next thing we're going to do is, oh yeah, and by the way, you can just command click or control click as well on special functions. You'll see if I hold command, I'm using a Mac, but if you were to use Windows, I think you could hold control. You'll notice that it starts prompting me to click, like they're becoming links. When you click these, you pull up that same documentation I showed you earlier. So you'll notice all I did was click get viewport rect. It's going to explain everything that's going on with this function. If I search help, get viewport rect, I can get the same documentation. When I clicked it, it just basically took me to where I already was. So it's just another way of doing things. All right. So now we're going to get to the meat of what we have to do. So we know the size of the window. We have pieces of data that we're using to store information about the character in the world. What we want to do now is we want to start handling what will happen with each update to the game. So for that, we're going to use this OnProcess or this process function. It's commented out currently because it gets called every single time we generate what's called a frame in the game. So it's going to say called every frame. The frame concept I described a little bit here. Basically, game engines model changes over time as you're playing a game with frames. A frame is basically like a picture. I mean, that's where it comes from. So this idea of a frame, like basically you're framing an image. And often game engines represent the array of data associated with your, like running your game or the behavior in your game with frames. So the idea is that the game engine is going to build a frame, and then it's going to display the content in that frame, and then it's going to listen to all of the inputs and changes that you've scripted or behaviors that you've scripted. It's going to process all of those, and it's going to compile all of those updates and build another frame, and then display that. And it's going to keep doing that. So when you hear people in gaming talk about frame rate, this is what they're talking about. Basically, how quickly can your engine render new frames? So that's the idea. This process function is basically the way, it's our door to building frame data. So the idea is that this process function is going to get called for every frame. So every time Godot is ready to build a new frame, it's going to call on that function for all of the nodes within the scene and all of the scene nodes within the scene tree, etc. And we can define our own updates that we want to do, like responding to input controls. We can move things around in the sort of 2D space or whatever space we're working with. We can process physics, etc. We can do all kinds of stuff. So the first thing we want to do is basically model the character with something so that we can interact with 2D space. We want to like have a representation of the character, the player character in 2D space to get started. We're going to need that to update its position in the world, and we're going to need that to process changes that we're making by controlling motion and stuff. So we're going to use a vector to do that. If you're not familiar with vectors, I have a link included here about vector math. They can be a little bit weird to think about if you're not familiar with what a vector is, but they're also pretty easy to think about. Basically, you probably know what an XY coordinate is from, algebra, learning kind of early algebra and stuff like that. So you graph a coordinate, a point, right? So if I have an XY point and I say X equals 2 and I go over 2 spaces to that point of X, and I say Y equals 1, so I move up 1 unit to Y, and now I have my point at 2, 1. So a vector is a lot like that, except what that defines is basically the end of what would be like an arrow pointing out in space, in 2D space. So if I used 2, 1 to describe a vector, what I'd be describing is basically, and I'll just click this link here to quickly show you a little illustration of a vector. So this is like the 2D point I described earlier, right? It's 4, 3, we go 4 over and 3 up. A vector is going to be an arrow that's pointing to that coordinate. So now that coordinate doesn't just describe a point in space, it describes like the length of this arrow, the angle of this arrow, apart from the y-axis and the x-axis. That's kind of all you need to know for our game. We're not going to do a bunch of, particularly advanced physics. But I would investigate this article, or you can also use Wikipedia. Wikipedia has a good article on vectors, just to be kind of familiar with it, because we're going to be talking about the 2D coordinate plane. So it's helpful really to just understand that a vector is a pair of 2 numbers. At a base level, that's what it is. And that's what we're going to use to describe where our character is in the world. We use a vector, though, because we need to describe speed. And if we're describing speed, then we probably want to describe direction. So the vector allows you to point to something and describe direction and magnitude, like, width or length of the vector, and angle, etc. So it's very helpful. All we need to do that is basically make a variable. I copied it, but I'm going to type it out. Var, which we're going to call velocity. So it's like basically speed with direction. This is velocity. And we're going to use this handy, which would be called a type in Godot, which lets us create vectors very quickly. So it already is automatically suggesting for me what to put into this vector. So I'm going to put 0, 0, because that's where we want to start our character. Like if we're describing the velocity of our character, at the beginning of each frame, we're going to assume it's not moving. And then what we're going to do is respond to player input to decide whether it is moving. So I already talked about vectors, kind of what's going on. One thing also to keep in mind, by the way, that is really important about this, which I forgot to mention, when you work in video games and graphics in general, when people talk about XY coordinates, it's a little bit weird, but the convention is actually that like up or positive Y is like down. That can be a little confusing at first. This is all over the place. It's not just video games. It's like graphics, computer imaging, anything like that, like Y. So this is moving sort of in the positive direction. So 1, 2, 3, and you can see here Y is 3. So it's not -3. That's a little bit weird to get used to. It's just a convention. Okay, just keep that in mind when I do this next part. So now what we need to do basically is we need to start, oh, this is a little bit of an error. This should be over to the left. I'll update that. I'll fix that. This should be over to the left. So what we want to do is basically update this velocity depending on the user input. And the way we're going to do that is respond to these signals. This should also not be here. That's okay. we're going to respond to input signals that we mapped earlier for the project. So the way we're going to form that kind of statement about the world is if we see this particular signal, this movement signal, we are going to respond by adjusting the velocity of our character. And then we're going to go through each of the possible inputs and adjust the velocity accordingly in case we get a different input from the player. So the way that's going to look in code, I mean, I have a sample right here if you want to just take a look at that, but we're going to just write it out. So what we're checking is this input property that Godot exposes to us in this script. Specifically, we're going to look for is action pressed. So this is where all of our events are mapped. If I start typing that out, it's actually just going to suggest it to me. I think these would work too. Like is action just pressed, is action just released? I mean, you wouldn't want is just released, right? Because that's when you would lift up. So if you lift up on the key, then it would trigger. We don't want that because we want it basically to work like while they're holding down the key. So this would only work basically if right at the beginning. So we probably don't want that actually, because basically it would start to move the character for one frame and then it would stop immediately because they would stop pressing. So while it's held down basically the whole time is what we want. And notice here, it's going to automatically suggest all of the things that we mapped earlier, which is really convenient. So move down, move left, move right, move up. So this is great. So we can just fill these in. So this reads just like you would say. And then it's telling us here that we need a colon at the end of the line. So whenever you write an if statement, you conclude it with a colon. And now, indenting again, we're going to include what we want to happen if this condition is met. So if the action is pressed, then what we're going to do is we're going to adjust the y component of the velocity because we're moving down. So we're going to say basically that the velocity, so instead of being 0, it should be whatever it is already, which really we don't need to make this update like this because we've set it here to be 0. So this would be bad, for example, if like your character had momentum, like if you wanted your character to have momentum, like when you press the key and then it just kept going a little bit, like you wouldn't want to initialize your velocity to 0 because it assumes that the velocity will be 0 every time we start a new frame. But our game is going to be pretty simple. It's not going to work like Mario does, where it kind of keeps moving a little bit as you jump and kind of slide or something like that. Ours is going to be pretty simple. So what we're going to do is basically just say, take the existing y component of the velocity, which is 0, and we're going to subtract 1. Or no, actually, sorry, we're going to add 1. Because on our screen, remember from the vector mathematics that moving down on the screen is a positive increment. So something to keep in mind. I know we're at the end of time here, but I think we can finish these inputs and we'll get to see our character move around. So let's try that out. And we'll just kind of go through these. Okay, so we've handled down. The way we're going to handle remaining inputs is using this elif keyword, which basically just means otherwise, or else do this. But we want to, instead of just saying else, we're going to say this elif because we're going to check another condition. So what this means is basically, if this is true, do this. Else, if this is true, meaning like, if this was true, it's not going to do the next thing. It's just going to do this first thing. And then it's going to quit. You'll kind of see what I'm getting at. So it's going to recommend more inputs for us. I'm going to choose the left one. So reset the velocity, except this time I'm going to change the x component. So basically I'm updating the x component of velocity. I'm saying take whatever it was before we update it. And we're going to add 1 again, because left, or sorry, we're going to subtract 1 because we're moving left. So x, the x dimension in graphics works normally. Sorry, moving or normally, according to what convention you're probably familiar with is what I should say. So we're moving to the right, so we're incrementing positively. Moving to the left, we're going to decrement. So we're going to subtract. Okay. And now I'm just going to keep using these else ifs. The problem, if we use an if, what would happen is that if it evaluated this as true, it would apply this. And then it would actually attempt to evaluate this condition as well and apply that. And it would just go down the line. We only want to move in one direction at a time for our game. So we only want to evaluate one condition. Just keep going. Is action pressed again? This time we're going to move, let's say we'll move up. So now we're going to edit the y component again. Velocity dot x. We're going to subtract 1 because remember in the positive or in the y dimension of this plane, minus is sort of the positive direction, or the up direction. So up is negative, down is positive. Hopefully, I'm sorry if that's like really confusing. Maybe it's not as confusing as I think it is. You probably get it pretty quickly. All right, so if the final action is pressed, which all that remains is going to be moving right. So I'm going to set the velocity one last time. I'm setting the x component, which is going to be this. I'm going to say plus. So we're just moving right, resetting plus. Okay, so that's the final. I got rid of that pass, by the way. We don't need it. So that's the final condition. So we only have 4 directions that we want to move. Up, left, down, right. That's it. I'm going to close this. At this point, we are done as far as motion goes. We could save this, except if I click play, it's not actually going to do anything. So it'll respond to all of my inputs, but the response is just to update this velocity. We haven't applied the velocity to our sprite, so nothing happens. Like nothing is going to occur when we do that. So what we need to do is actually change something, an attribute about this 2D node. Okay, to do that, we're going to do a couple of different things first to kind of manifest that in the game realm. So this isn't super important. This will change basically the animation. I want to do this part first. I'm going to jump ahead because we're at the end of time and I want to get you to something exciting looking. So basically, I'm just going to jump here. I'm going to use the velocity to update the castaway or the sprite's position in the frame. So to do that, we're going to use the position property of this node. I'm just going to hop down here. I'm going to leave the scope of the if statement. That is very important. We want to leave the if statement. We want to do this no matter what. So it's not going to be conditional. We're going to use the position property, which is just a property inherent to the node. I don't have to make this variable. It's already there for me to update. I can say position, and in fact, it should suggest it to me. See here, it's suggesting I use it. And what I'm going to do is I'm going to change the position. I'm going to update it. with a couple of pieces of information. So this part is a little bit complicated from a vector perspective. But if you kind of are getting the vectors, then it shouldn't be too bad. The idea is that basically I want to use the velocity that I set up, which so far can only be one of four options. 1 in the y direction, -1 in the y direction, 1 in the x direction, -1 in the x direction. And I'm going to take the position, which could be anywhere in the display. Like if I run this, oh, it's not going to work because I have this error. Run it again. If I run this, you'll see that this is the current position of my castaway sprite. I want to update that. So the velocity is going to start as 0, meaning the character isn't moving, but they are in a different place depending on where I last moved. You kind of have to constantly think in terms of being, relative to the last frame. So we're going to reference the data from the last frame to update this frame, because the frame hasn't updated until we end this function. We're going to say position is equal to the existing position. And we're going to multiply that, or I'm sorry, we're going to add to it. We're adding a vector to our position, which is another vector. I think showing it graphically will help the best once we get this running. The idea is basically that we're going to take the velocity that we just found, which basically you can read this as direction. So we're going to take the direction that we want to go. We're going to multiply or scale it by the speed we want to travel at. If you recall, we set that speed up here. And then we're going to multiply that by this delta. This delta is kind of interesting, but maybe it's not so interesting and probably easy to understand. Since I have this comment here. Basically, delta is just how long it took to get to this point from the last frame. And the reason we're going to use delta is it basically means that our character won't change speeds just because your frame rate drops. So if your computer slows down and it gets sluggish, it can't generate as many frames at the same rate, you can use this delta to compensate for that in your game. So that way it'll still move at the same rate. Your movement won't change. Maybe other things will start to struggle, like, things will look blurry or something like that. All right. That was probably the most complicated aspect of updating the character's position in the frame. The last part is pretty simple. We're going to use this clamp function to restrain the character to the screen, the display dimensions. So we don't want our character to just run off of the screen. This is why we needed that game window size. So what we're going to do is say, okay, the X component of the position, we want to make sure it doesn't go too far left or right. So basically what we're going to use is this function called clamp. It just is basically going to squeeze a value that you give it into a certain range. So first we're going to give it the value that we want to clamp, which is position.x. And then we're going to say, okay, the minimum, which it's suggesting I provide here, should be 0. So that's the bottom, or sorry, for x, it's the leftmost position of our frame. If we go back up to the vector map, you can see the little display here showing us, this would be our screen. Actually, we don't even need to do that. We have a little screen here. So look, this is 0. This is the leftmost. So that's the minimum. And then the maximum is basically going to be the game window size, which we stored as a variable. We're going to say size, or wait, I think we can just say x. Yeah, I think that's what I recommended. Yeah, game window size.x, because this is also a vector. You can imagine this vector is basically just being an arrow that points from here to here. If you were to look at that vector graphed out. Okay, one more update. All we got to do is set the position y to a corresponding clamp. for the Y component, the minimum being 0. And we're going to take that game window size, but the Y component of the game window size this time. We're going to save that. And if we run this, now our position's being updated and we can move. So I'm just using the arrow keys.
Oh, wow.
Yeah. So
So cool.
we coded this. If you go back, basically you would put that code right here. You can use the animations we set up, which I'll just go ahead and copy them. And then basically it's just checking if the player, if we updated the velocity at all. And if we did update the velocity, then it's going to play these animations. I don't know why it's yelling at me. Mix tabs and spaces. Oh, geez. It really doesn't like. It's really serious about the tabs. You have to use tabs or spaces, not one or the other. And okay, there we go. So yeah, you can't use both. All right. So if we save this and run it again, this will look even more interesting. So now we have this little idle. So this is what our character is just doing by default. It's kind of a cool little stasis. And then as he walks, the character kind of animates, which is pretty cool. So now it actually looks a little more lively. It's kind of moving around on the screen as it kind of looks like it's walking. Okay, that's pretty much it. Next time we will start running into stuff with the character, and we'll start adding stuff to run into. And that we'll start to see ways that we're going to have game logic. So if I run into something, then what happens? What should I do in my game? Or if I stand next to something, should I do something? Stuff like that. So that's it. I will upload the changes.
Thank you, Paige. I mean, I think it's really awesome.
Yeah, sorry, we went over.
Oh, no, it's okay. All right, so if nobody has any questions, I'm gonna double check Facebook. It seems like we don't have questions. Thank you so much. And we will see you once again on February 24th, correct?
Yep, yeah.
Yep, 6:30.
Yeah.
And just to remind everyone, we have office hours with Paige on Mondays, 6:30 to 8:30, and you can send him an email or sign up through Calendly.
Yeah, that link is actually right here. So if you just go to this GitHub page,
yes,
you can just click this, and you can email me as well.
Yeah, code@nhfpl.org.
Right.
Okay, perfect. All right, thank you so much, and I hope everyone enjoys the weekend coming up.
Thanks.
See you, Paige. I will email you, probably.
Okay, yeah, sounds good.
All right, thanks. Bye-bye.
Thank you. Good night.
Thanks. Bye.